In this video, I want to show you how to run a scattergram, correlation, and regression with SPSS. And then I want to show you how to interpret and report that data, appropriate in a research report. Let's use a lab exercise as an example. So we will be working with the variable education, which measured the respondent's highest year of education, and then the education of the spouse. So we want to see if there's a correlation between the respondent's education and the education of the person that they are married to. We load our GSS data set in SPSS. Then we double check that our variables are set correctly. So the first one was education. There's education. And we can see that's set as a nominal, but this is measured as highest year of school completed. So we have to make sure that this is a scale variable, so set correctly. And then the other one was spouse education. There we are. And that is set as scale. So now we can begin. Click on graph, chart builder. Okay, we're looking for a scatter plot. Drag this up here. And we are looking for education. Education. Put that in the y-axis. And then we look for spouse education. Spouse education. Put that in the x-axis. Now we click OK. Now we get a fast visual of, is there a correlation between these two? And we can see just by looking at the pattern, there's definitely a trend going upward, right? Most of the data is right here. So it looks like there's a correlation. However, let's add a fit line at total in order to really see if there is a pattern. So double click on the graph itself. You will see that this opens up. And then we can see right here that symbol says add fit line at total. Now we can just X out of it and we automatically have the best fitting line. And it's going to give us our square up here. So now we definitely see that there's a positive trend, right? It's going up. So we can clearly see that as highest year of school completed increases for the respondents, it also seems to be going up for the spouse. That's the scatter, even so it's not a perfectly straight line, right? It's somewhat scattered, but we can see it looks like a pretty strong relationship just by looking at it. We can see that the relationship is clearly linear. But now let's actually look at the values. Again, the scattergram is just to get a quick visual of if our two variables are related with each other. Next, we want to find out how strong is the relationship. And for that, we go to Analyze, Correlate, and Bivariate. Again, our two variables are education and spouse's education. Click OK. And now we get the correlation table. Here you can see highest year of school completed correlated to highest year of school completed gives you a 1 because it's the same variable, right? So there's a perfect correlation. So we're kind of ignoring this table and this table right here. What's of interest to us is the highest year of school completed spouse correlated to highest year of school completed by the respondent. And you can see it is, first of all, highly significant, right? It's significant to the 0.000 level. And then the Pearson's correlation is 0.596. So that is moderately strong. So remember, a correlation of 0 indicates that there's no relationship. A value of 1 is perfect. So 0.596, that's in the middle, so moderately strong. So this would be the first thing we would report. We can say that the relationship between someone's education and their spouse's education is positive and moderately strong. Pearson's R equals 0.596. Let's go one step further and let's run a linear regression to understand the relationship between these two variables. So we click on Analyze, Regression, and then Linear. Let's find education. Highest year of school completed. Let's put that in the independent, and then the one for the spouse and the dependent. And then click OK. So first, again, we want to see if the relationship is statistically significant, and whether someone's education can be seen as a useful predictor for the spouse's education. So here we can see our R again. That's the same as up here, right? Is 0.596. So that is the correlation, and we said that was moderately strong. Now we also have R squared. And remember, that is the coefficient of determination. That indicates the proportion of variance of the dependent variable that can be explained by the variation that occurs in the independent variable, which in this case was education. So we can say that 35.5% of the variation in spouse's education can be explained based on the amount of variation that occurs in the respondent's education. The standard error of the estimate indicates the amount of dispersion for the prediction equation. So 95% will fall within two standard errors. Our predicted spouse's years of education will be correct within 4.936 years, and that's plus and minus, 95% of the time. Significance here we can see is 0.000. So again, this means it's a significant result, meaning that respondents' years of education is a statistically valid predictor of the spouse's years of education. And then our last table right here, here we see, is it a positive relationship or negative relationship? Here we can see that the coefficient is 0.597, so it's positive. So that indicates a positive relationship between the two. So one goes up, the other one goes up, one goes down, the other one goes down. And then lastly, we want to plug all these coefficient values into a regression equation. So remember, the general one is that y hat, so the prediction equation, is a plus bx, where a is the constant. So the constant here would be 5.472. And then the second coefficient value here is 0.597. So that is b, the slope, and then times x. And x in this case is the spouse's years of education. So our prediction equation therefore is y hat equals 5.472 plus 0.597 times x. If you have any questions, please email me anytime. I am here to help.